Hello students, welcome to IMS GATE Academy. I hope you are doing great. My dear students, when I am talking about the concept related to the most expected questions, today I am here to discuss about a topic called affective stress. See students, when I talk about affective stress, here I would like to tell you the most important concept in affective stress. See, affective stress is the basis for shear strength problems. Affective stress is the basis for pile foundation problems. Affective stress is the basis for consolidation problems also. So in this affective stress, my dear students, you should understand the basic terms and how you can solve the problems using this affective stress concept. So today I am going to here to discuss about the topic affective stress. Now see students, what do you mean by affective stress? See students, in soil there can be a stress due to the self weight of the soil, or there can be a stress due to the weight of a structure or anything. Now the stress due to the self weight will be considered as affective stress. That stress due to the weight of superstructure, that will be considered in stress distribution. So my dear students, when I talk about the affective stress, what is actually the affective stress? See here students, if I consider these are the soil particles, okay, in between the voids there can be some water. In between the voids there can be some water. Now if it might be subjected to some load. Now see students, for your information, what is the affective stress? Affective stress is the intergranular pressure. Remember the word intergranular pressure. Let me explain you. Sir, when the soil is in contact with the other soil particle, how the pressure has been transmitted, that is called intergranular pressure. So my dear students, affective stress is the intergranular pressure. It is the intergranular pressure between the soil particles. What is affective stress? It is the intergranular pressure between the soil particles. Okay. And see students, as I told you, affective stress is due to the self weight. This is a very important wording, sir. Affective stress is due to the self weight of soil. This is also important. Now see students, how do you calculate the affective stress? Does it have any influence on the engineering properties? Now my dear students, when you talk about shear strength is a function of affective stress. I'll give you example. Shear strength is a function of affective stress. And my dear students, when you talk about the bearing capacity, when I talk about the bearing capacity of the soil, shear strength is the important term to understand the bearing capacity of the soil. So here I would like to tell you one important thing. If you want to understand bearing capacity, you should know the shear strength. And according to the Morse-Coulomb's equation, shear strength is a function of effective stress. Now understand the importance of effective stress. If you can judge the effective stress, the bearing capacity of the soil can be estimated. Now simple words, you can say stress is equal to what, my dear students? Load upon area. Stress can be considered as load upon area. Yes or no? Yes or no, my dear students? Or you can say, if you talk about gamma is equal to what? Gamma is equal to weight by volume. And weight can be written as gamma into volume. And volume can be written as area into depth. If we consider the depth of the soil strata as Z. Are you getting, my dear students? We consider the soil depth as Z. Here I have considered the soil depth as Z. So when I talk about the weight, weight is gamma into volume. Here volume is nothing but area into depth of the soil strata. So if I substitute there, sigma is equal to weight upon area. Weight can be written as gamma into area into Z divided by area. You can write here total stress is equal to gamma into Z. Total stress can be written as gamma into Z. Okay, so how do you calculate the stress? Also, you should have an idea, my dear students. So, what is actually effective stress? It is the intergranular pressure between the soil particles. It has a significant influence on the engineering properties. As shear strength is a function of effective stress will have a significant effect. So, my dear students, let me explain you another important point. Okay, see here, you should know what is pore water pressure. What is pore water pressure? What is pore water pressure? Pore water, it is the pressure exerted by water on the soil particles. What, sir? It is the pressure, pore water pressure is nothing but the pressure exerted by water. It is the pressure exerted by water. The pressure exerted by water on the soil particles is nothing but pore water pressure. And remember, my dear students, pore water pressure is given by the equation U is equal to gamma W into HW. What is gamma W? Unit weight of water. What is HW? Height of the water table. So, this pore water pressure is also called as neutral pressure. Here, please understand, students, pore water pressure is also called as what? Neutral pressure. Okay. So, students, actually people try to understand what is the actual difference between the effective stress and stress distribution. Effective stress is due to the self weight, and when I talk about the stress distribution, when a superstructure weight is fallen on the soil, how the stress has been distributed, which we will be studying in stress distribution. Here pore water is called neutral pressure. Why pore water has called neutral pressure means it does not influence the, it does not influence the engineering properties. This can be an important like objective question. It does not influence the engineering properties. Why effective stress is important? I told you, because shear strength is a function of effective stress and it has measurable influence on engineering properties. But whereas neutral pressure is called, pore water pressure is known as neutral pressure because it does not influence the engineering properties of the soil. I hope you are clear with the effective stress and the neutral pressure. And one more thing, students, here, if you talk total stress, if I take total stress is given as what? As sigma. And if I represent effective stress, as sigma dash, and if I represent pore water pressure as U. Now you can ask me, how do you correlate these three? How do you relate these three using the equations? How do you represent total stress? How do you represent effective stress? and how do you represent pore water pressure? Now let me explain you one example, students. If I consider this as the soil particles, okay, and you have the water in between this, okay. Now see, students, what will be the total stress? Total stress, you can write in words also. Total stress can be written as is equal to stress taken by the soil particles. Total stress can be written as stress taken by soil particles plus stress taken by the water plus the stress taken by water. So total stress here is taken as what? One is the stress taken by the soil particles and other one is the stress taken by the water. Here see, total stress is represented as sigma and effective stress is represented as sigma dash and pore water pressure is written as U. So my dear students, this is a very important relation. So total stress is a summation of effective stress and pore water pressure. What do you mean by total stress? Total stress is a combination of effective stress and pore water pressure. The important note point also I would like to tell you, my dear students. What is the important note point I would like to tell you is, here if I talk about effective stress can be written as total stress minus pore water pressure. Sir, what is the important point, you can ask? Remember, my dear students, effective stress cannot be computed directly. What, sir? Effective stress cannot be computed or cannot be calculated directly. Why it is not calculated or computed directly? You can ask me. See, students, you cannot separate practically the soil particles and water. Practically they are not possible. So we will calculate the entire stress, that is the stress taken by water and the soil, and we also calculate the pore water pressure. So once you get the total stress and pore water pressure, by finding their difference, you can get the effective stress. So let us write this conclusive point that total stress can be written as the summation of effective stress plus pore water pressure. And remember, my dear students, effective stress has a measurable influence on engineering properties. This is the third time I am telling this point. Why? Because when you talk about shear strength, when you talk about consolidation, when you talk about bearing capacity, this effective stress has an impact. So as part of this, to calculate the problems, I have given you some easy classification. Students, if you can understand these cases, any problem related to total stress, effective stress can be done. Now see, students, suppose you have a soil strata. You have a soil strata of depth Z and gamma is the unit weight of the soil. Now we will draw the total stress diagram, and here total stress will be equal to this. If I write, total stress will be equal to gamma into Z. And pore water pressure, is there any water table in the diagram? There is no water table. So in this case, the pore water pressure will be 0. And if you write here, effective stress can be written as total stress minus pore water pressure. And here you can write it as, this one also as gamma into Z. This will be also equal to gamma into Z. So first thing you can ask me is, the stress, effective stress or the total stress is going to vary hydrostatically or linearly in a soil strata. The first point I would like to tell you is the effective stress or the total stress is going to vary linearly or hydrostatically. Yes or no? Now here I would like to tell you total stress will be equal to the effective stress. This is an important note. What, sir? Total stress will be equal to the effective stress. Here you should understand that total stress will be equal to effective stress in case there is no water table. Whenever there is no water table, you can say that total stress will be equal to the effective stress. Please write down this, student. Here see, what I would like to tell you is, my dear students, total stress will be equal to the effective stress whenever there is no water table. And here please understand that the effective stress and total stress is going to vary linearly. And the important note I would like to tell you is total stress will be equal to the effective stress whenever there is no water table. This is the important point. Now, case 2. Here in the case 2, we'll discuss about water table at the top. Whenever, or you can write in case of water table. Suppose, my dear students, here we consider this as a soil strata. If I consider this as a soil strata, depth Z. Here, if I consider this as a soil strata, depth Z. And we can write gamma as the unit weight of soil. Okay? And we have water table at the top. Now see, students, here gamma will become as what? Whenever there is a water table, gamma sat. What do you mean by saturated unit weight, my dear students? If the voids are completely filled with water, then we call it as saturated unit weight. Am I clear or not? So here please understand that the total stress, that is sigma, the total stress will be equal to, you can write here, gamma sat into Z. Now in this case, my dear students, there is water table. So here water table will not be 0. As you know, water table will be equal to gamma W into Z. What is water table? Gamma W into height of the water. Here the height of the water is Z, gamma W into Z. Now the effective stress can be written as total stress minus pore water pressure, and you can write here as gamma dash into Z. How this gamma dash into Z came? Total stress is what, my dear students? Total stress is gamma sat into Z. And what is pore water pressure? Gamma W into Z. So what is effective stress? What is effective stress, sir? Effective stress is total stress minus pore water pressure. You can write it as gamma sat into Z minus gamma W into Z. This you can write it as Z common. You can write it as gamma sat minus gamma W. So here let me tell you what do you mean by gamma sat minus gamma W. It is nothing but gamma dash. So this is how the formula has came. So the important point I would like to tell you, this you can write as a note. In case of water table, effective stress will be calculated by replacing gamma sat is replaced by gamma dash. You can say that if you see total stress will be calculated using gamma sat, but effective stress gamma sat will be replaced by gamma dash. And another important, see, for every case I will give you one important note. In the first case, what I told you, total stress will be equal to the effective stress whenever there is no water table. In the second case, in case of water table, whenever you are calculating the effective stress, gamma sat will be replaced by gamma dash. And one of the important thing also you should understand. If I show in the total stress, the length is more. Here, somewhat lesser. If you see here, somewhat lesser. Why this is happening is, this is simple, amma. As usual, you should know that gamma sat is usually greater than gamma w and gamma w is usually greater than gamma dash. Sir, sometimes gamma w might be less than gamma dash, but most of the general scenario will be, this is how. That is the reason I have shown the widths in this way. I hope the case 2 is clear. Now, let me tell you the next case. See student, case 3. What do you mean by case 3 here? Here I would like to tell you, suppose there is a soil strata of depth 2, at least depth Z1, and another one we have is depth Z2. And here we have gamma 1 and here we have the soil strata as gamma 2. Are you getting me? There is a soil strata with the depths Z1 and Z2 with the different unit weights gamma 1 and gamma 2. Now, how is the total stress? Suppose see students, most of the students will write like this. They can write like this. The stress at this layer, you can write it as gamma 1 into Z1. And if you write the stress here, gamma 1 into Z1 plus gamma 2 into Z2, you can write this. But still I won't erase this, sir. I will show this is wrong. I will keep it like this only for your information. This is absolutely wrong. Sir, this is correct if the soil is having same unit weight on the entire soil depth. But here the unit weights are differing. So let us understand how the total stress will be shown. So in this case, you can show it as like this. So this portion indicates gamma 1 into Z1 and this indicates gamma 2 into Z2. And here there is no water table. So my dear students, the diagram will be same even for effective stress. Because whenever there is no water table, total stress will be equal to the effective stress. You can simply say that total stress is equal to the effective stress. So here, my dear students, you can simply say that the stress at the bottom will be equal to gamma 2 Z2 plus gamma 1 Z1. Actually, bottom it will be gamma 1 Z1 plus gamma. See here, this depth is Z1 and here this depth is Z2. So as you move towards the down, the effective stress or the total stress is going to increase, gamma 2 Z2 plus gamma 1 Z1. Now here I have a small question, students. What is the note point you would like to carry from this statement, from this case? The note point I would like to tell you here is the slope changes. You should remember, when a soil is having different unit weights, slopes changes, or you can write slope changes. Simply you can write slope changes. When a soil is having different unit weights, you can simply say that the slope is going to change. So the carry forward from this case is, if a soil is having different unit weights, the slope is going to change. Okay, I hope you are clear. Next, suppose in case 4, what is case 4 is whenever there is due to surcharge, how is the effective stress is going to vary or total stress. Okay. Now see students, if I consider this as a soil stratum and if I consider this as a soil stratum, if I consider this as a soil stratum of depth Z, if I consider this as a soil stratum of depth Z and unit weight gamma, okay, and we have a surcharge load, this a surcharge load Q, okay. Now see students, what is Q here? Q is known as the surcharge load. Q is known as what, my dear students? Q is known as the surcharge load. Okay. Here there is no water table. As there is no water table, my dear students, you should remember that total stress and effective stress will be same. So when I talk about the effective stress or total stress due to the surcharge, it will be in this way. This will be Q at the top and Q at bottom. And if you talk about the stress due to the sulfate, it will be 0 at the top because the depth at top is 0. As you move towards down, the depth is going to increase and this part is QZ. And you can add Q plus gamma Z is the stress at bottom. So what is the note point you would like to carry from this case? So you can simply say that the note point is due to surcharge loading, the total stress will be uniform, means it is independent of the depth. It is not going to vary based on the depth. If you see the total stress or effective stress due to the unit weight of soil, as the depth is increasing, the effective stress is also going to increase. But here, due to a surcharge load, the total stress is uniform. This is a very important point, my dear students. Due to the surcharge, the total stress is going to be uniform. So this is how you have to remember the different cases when you come across the effective stress problems. So I will give you a sample problem, how you will be trying, how you will be solving. Now see students, I am giving you simple thing. Okay, a soil is having a depth of 1 meter and another soil strata is having 2 meter. Okay, and assume here it is dry soil having a unit weight of 18 kilonewton per meter cube. And here there is a water table here and the saturated unit weight is 20 kilonewton per meter cube. You can write it as A, B, C. And there is a surcharge of load 20 kilonewton per meter square. 20 kilonewton per meter square. Assume gamma W units, actually see students, I told you gamma W will be equal to 1 gram per cc or 1 ton per meter cube, or it can be 9.81 kilonewton per meter cube. Here he is telling assume gamma W as 10 kilonewton per meter cube for easy calculation. Now my dear students, calculate the effective stress at the bottom, or you can write calculate the effective stress at a C. Calculate the effective stress at C. Now see students, the question is very simple. If you are aware of the concepts of the previous cases, just you have to apply the kind of application here. That's it. Now first thing, I will directly go into the effective stress. I will not calculate total stress or I will not calculate pore water pressure. How we will do? First, the stress due to the surcharge, it is 20. So my dear students, 20 will be same. Even it is at top, it will be 20. Or bottom also, it will be 20. How can I say that due to how it is 20 at top and 20 at bottom? The answer is simple. Due to the surcharge loading, the stress is uniform. Due to the surcharge loading, the stress is uniform. Next, here there is no water table between the soil strata of A to B. As there is no water table, total stress and effective stress is same. Remember these words, students. As there is no water table, total stress and effective stress will be same. So you can write here, this will be equal to, this is 20 and this will be equal to gamma D into Z1, that will be equal to 18 into 1. So this is 18 and this is 20. So what will be the value at B? It will be 38 and at top it will be 20. But what he is asking? He is asking the stress at C, effective stress. To find out the effective stress at C, now let me explain you. This is how much, sir? This is 18 and what will be this? Now, in the case strata soil B to C, or you can say in the soil strata B to C, there is a water table. Now, my dear students, you should remember that whenever there is a water table, in case of effective stress, I told you clearly, gamma sat will be replaced. Gamma sat will be replaced by gamma dash. So here what is gamma sat? It is 20 kilonewton per meter cube. So here you can write gamma dash is equal to gamma sat minus gamma W. And he has assumed, we can assume, because in the problem gamma W is 10 for easy calculation. So you can write here 20 minus 10. So this will be equal to 10 kilonewton per meter cube. And here, my dear students, the depth is 2 meter. So you can write here as 10 into 2. So add all these things. Sir, no need to find the values at A and B. Directly we can go at step C. 20 plus 18 into 1 plus gamma dash into 2. So you will get around 58 kilonewton per meter cube. This will be equal to 58 kilonewton per meter cube. So my dear students, this indicates surcharge and this 18 will act as a surcharge to the bottom layer due to the self-weight. This is gamma D into Z1, or you can write, my dear students, this as gamma dash into Z2. I hope with the cases, case 1, case 2, case 3 and case 4, these problems can be solved very easily. Okay. Now, my dear students, when I talk about the soil and you have the voids, in these voids actually the water is going to present. Now, this water, how does this water exist? That is also very important. Here, see students, water exists in three forms. Usually the water exists in three forms. First one we can write it as structural water. What, sir? The first one we have is the structural water. First one we have is the structural water. See students, when I talk about blood, again in blood, you might have come across erythrocytes or red blood cells or white blood cells. Similarly, what is a structural water? Structural water is an integral part of the soil. It is an integral part of the soil, and if you try to remove the structural water, it will be very complicated. That is the reason it cannot be removed by ordinary woven drying. So here, my dear students, structural water is an integral part of the soil. What is structural water? It is an integral part of soil. And it cannot be removed by ordinary woven drying. Ordinary woven drying means you might have maintained temperature 105 to 110 for 24 hours. If you do that, you cannot remove this structural water. So water is going to exist in three forms. One is structural water. Next one we have is the adsorbed water. When I am discussing about the diffuse double layer in soil structure, I have given you some insight about adsorbed water. So my dear students, let me explain you one important thing. Before understanding the adsorbed water, you should have an idea on the diffused double layer. You should have an idea on diffused double layer. What do you mean by diffused double layer? The diffused double layer says that the layer on the clay surface up to limit of attraction due to the electrical forces is known as diffused double layer. Now, whatever the water held in the zone of diffused double layer, water held in the zone of diffused double layer, water held in the zone of diffused double layer is known as adsorbed water. Is known as what, sir? Is known as adsorbed water. Sir, why you are studying adsorbed water? As I told you, my dear students, this adsorbed water is not a good sign. It creates plasticity to clay. Now, my dear students, what do you mean by plasticity? Sir, what do you mean by consistency? Consistency means the ability of a soil to resist deformation is consistency. But consistency varies with water content. Now, what do you mean by plasticity? It is the ability of a soil to deform, but there will not be any rupture. It is you can say here consistency means the ability to resist deform. Plasticity means it can able to deform, but it will not cause, the soil should not cause rupture, or the soil will not be subject to rupture. So here plasticity is a very dangerous sign. So that is the reason we should have a serious look on adsorbed water. When I talk about diffuse layer, this adsorbed water is replaced by a non-polar liquid. Sir, actually if you talk about polar or non-polar based on cathode and anode attraction, they classify that. That is a lot of chemistry, means we are not concerned about the chemistry part. Here adsorbed water is creating the plasticity, hence this water is replaced. So my dear students, water exists in three forms. The first one is the structural water, and the second one is the adsorbed water. Now let me explain you the most important thing is Keplerity. Sir, before understanding capillarity, what do you mean by capillarity? What do you mean by capillarity? Sir, the sudden rise of a liquid or fall of a liquid. The sudden rise or fall of a liquid is known as capillarity. Are you clear, my dear students? The rise or fall of a liquid, the rise or fall of a liquid, the rise or fall of a liquid is known as capillarity action. Sir, if you want to understand this capillarity much more, Pragya Tripathi, or you can visit Atul Negi videos in the YouTube channel. They might have given you much more in detail when they are explaining fluid mechanics. Whatever the things which are required here, I am just giving the insight. The rise or fall of a liquid is known as capillarity. Okay, now let us understand one thing. Actually, see students, capillarity height is given by the formula 4 sigma s cos alpha upon gamma w into d, or this will be simplified to 0.3 upon d centimeter. Okay. Now here let me explain you what is sigma s. Sigma s is known as surface tension, and alpha is known as contact angle, and d is known as the dia of tube. So let me explain you how this phenomena will work in soil, how this phenomena has an impact on the soil. So my dear students, if I consider this as a tube, this is the meniscus, they can call this as the contact angle. Okay. Now let me explain you one important concept, Amma. There is a concept called capillarity fringe. There is an important concept called capillarity fringe. If you can understand this, you will have how this capillarity is going to have an impact in the soil. Okay. Now see students, here capillarity fringe, if I talk about capillarity fringe, suppose if I consider this as the soil particles, if I consider this as the soil particles, I am just giving an example, okay. Now see students, the interconnected voids will act like a capillarity tube through which the water might rise or fall. This phenomena is known as capillarity fringe. Are you getting, my dear students? The interconnected voids, whatever the interconnected voids in the soil, the interconnected voids will act like a capillarity tube. The interconnected voids will act like a capillarity tube through which water will rise or you can say or fall. So this is known as capillarity fringe. Here please understand this students, the interconnected voids will act like a capillarity tube through which the water will rise or fall. Now see students, whatever the liquid here, now this water here, if you see here, let me show you. This water here, this water will cause compression to the walls, and the capillarity water will be under tension. What, sir? This is an important thing. Capillarity water causes compression to the soil mass and the capillarity water will be under tension. That is a very important thing. So you can write here, the observations from here is, the second point you can write that capillarity water causes compression to the soil mass. And remember, my dear students, the third point I would like to tell you here is, the third point you can write here is, the capillarity water will be under tension. Now see, students, if you see the capillarity, if you see here how the stress is going to vary using the capillarity, the how it will looks like is, this is how it will looks like. If this is the height of the capillarity HC, and in the top there will be a tension, that is minus gamma W into HC, and at bottom you will have compression gamma W into HC, where HC indicates the capillarity height. Now there is an important thing, my dear students. Suppose in the diagram we have different cases. If this there indicates a zone like this, if you see this zone has having a capillarity action. So my dear students, when you talk about the effective stress calculation, this is very important number. When you talk about the effective stress calculation, effective stress during capillarity action, okay, very, very important. It will be taking gamma sat into account. What, sir? Gamma sat into account. So see, students, during the capillarity action, for capillarity to happen, there should be some water table. Okay. So here, even though the effective stress is going to use submerged unit weight, while you are calculating the effective stress, whenever there is water table, but in case of capillarity, you are going to use gamma set. How this is going to possible? Suppose in case of water table, the effective stress you are going to use is gamma dash. But here if you see the water pressure, it is a negative pore water pressure. So here negative of negative will become gamma W into Z, or Z is nothing but the capillarity height. Here Z also the capillarity height. So what is gamma dash? Gamma sat minus gamma W, and here you will have minus. Gamma sat minus gamma W into Z minus of minus gamma W into Z. So this term, if you see here, gamma sat into Z minus gamma W into Z plus gamma W into Z. So these terms will cancel, and please remember as a note, in case of capillarity action, whenever you are trying to find out the effective stress, gamma sat will be used. Never ever gamma sat will be replaced by gamma dash. It will never happen. And remember, students, now due to the capillarity action, if you observe, the effective stress is going to increase. They can give you this question also. If suppose the capillarity height is HC, definitely there will be an increase in the effective stress. How much is the effective stress increased is, it is simple. you can say whatever the height of capillarity. Sir, are you getting, my dear students? The question will be simple. Whenever there is a capillarity action, how much is the effective stress increased? This can be a gate question. So you can simply that height of the capillarity height multiplied by gamma sat minus gamma w. Or simply you can take gamma sat minus what, sir? Gamma dash, sorry, not gamma sat minus gamma dash. Okay, or it is simple that what is gamma sat minus gamma dash? It is nothing but gamma w. So due to the height of the capillarity, the increase in effective stress is nothing but the unit weight of water multiplied by the height of the capillarity height, you can write. Now let me tell you the summary in the effective stress topic. So my dear students, effective stress is the intergranular pressure between the soil particles. And here I would like to tell you, effective stress is taken as total stress minus pore water pressure. You should remember that effective stress should be written as total stress minus pore water pressure. And you can write that effective stress has a measurable influence on engineering properties, whereas pore water pressure is called as neutral pressure because it does not have measurable influence on engineering properties. And remember, my dear students, total stress can be written as gamma into Z. Okay, or we should not write the cases, sir, or we can write like this. Total stress can be written as effective stress plus pore water pressure. And remember, my dear students, never ever the effective stress can be calculated directly. It is always computed by knowing the total stress and the pore water pressure. And let me explain you the other points also here. Note points. In case of surcharge, the stress will be uniform. The first point is, in case of surcharge, the stress will be uniform. Okay. And in case of water table, effective stress will be calculated. Effective stress is calculated using gamma dash. And remember, my dear students, total stress will be equal to effective stress when there is no water table. When there is no water table, you can write effective stress is equal to total stress. And remember, my dear students, I would like to tell you that water exists in three forms: structural water, adsorbed water, and capillarity water. Structural water is an integral part of the soil. Capillarity water is due to the interconnected voids will act like a capillarity tube through which the water might rise or fall, capillarity fringe. And remember, to add some more practical application, due to the capillarity action, we will see frost heave and frost boil. And remember, my dear students, frost heave happens during the winter season and frost boil might be during the summer season. And frost heave, whenever there is a rise of water, this water will get changed into ice. And these conditions are observed in fine sands and silts because the permeability is somewhat high. Why this is not observed in clays is, the permeability in clays is very low. When it happens, when the water gets melted or boiled, there can be chances of water getting seeped through permeability action. That is the reason, my dear students, frost heave and frost boil are due to the capillarity action, and these are observed in fine sands and silts. I hope This session on effective stress will help you to solve the basic as well as the advanced questions on the effective stress problem. Hello my dear students, I am proudly say that IMS is offering the offline gate coaching at Bangalore at Jayanagar Center near Southern Circle, and we are also offering the offline gate coaching at Vijayawada near Ben Circle. Apart from this, we are offering the online gate coaching with recorded sessions, and we are also offering the online gate coaching with live classes. So students, if you are really looking for GATE 24 and 25, at IMS GATE Academy, we provide 750 plus hours of live classes, and we also provide the study material, subject-wise tests, chapter tests, multiple subject tests, as well as we also provide the All India mock test. In addition to this, every subject we provide the exercise book, every subject we provide the theory book, and we also are giving the GATE question booklet. So if you are really want to enjoy the offline topics on the GATE, if you can visit our center and ask for a demo, and you can learn the subject. I hope this video, and I hope the most important concepts videos will help you to enhance your subject in a better understanding way. Thank you.